This is the pre-lab for the Hydrate Lab experiment. In this investigation, you'll be determining information about two hydrated salts, copper 2 sulfate and calcium chloride. Here are the pictures of the chemicals we'll be working with. You might be asking yourself, well, what's a hydrate? Many inorganic salts form crystalline compounds that contain water molecules or water of hydration as part of their crystalline structure. In a hydrate, water molecules are distinct parts of the compound, but are joined to it by bonds that are weaker than either those forming the anhydrous salt, that means it's without water, or those forming the water molecules. In the formula of a hydrate, a dot is commonly used to separate the formula of the anhydrous salt from the number of water molecules. I have an example here as magnesium sulfate heptahydrate. The dot that is shown here actually means that there are 7 water molecules attached. So think of the dot as an addition sign rather than what you might want to do for mathematically, which would be to multiply. That dot means you add 7 water molecules. Hydrates can usually be converted to anhydrous form by heating, and that's what we'll be doing in this investigation, heating up samples of hydrates to obtain some information about them, and then use that information to determine specific things about each of these compounds. A few notes about safety. Make sure you're wearing your goggles at all times during the experiment, even when you're cleaning up. We are working with flame, so please tie back long hair and keep loose clothing in check. The test tubes that we're going to be working with will get very hot. So you don't want to touch them until after you've given them enough time to cool off. And you don't want to clean them until you've given them enough time to cool off. The first step of the experiment says to measure and record the mass of 2 different medium-sized test tubes. To do this, use a beaker as a test tube holder on the balance so the test tubes do not roll off the balance. So use a beaker and tear the balance with the beaker on it first, and then add your first test tube and find the mass of your first test tube. Remove that test tube and then repeat. So you're going to do this step here 2 times with 2 different test tubes. Next, you'll add 2 to 3 grams of salt, which is a good size spatula full, or about the size of the height of a thumbnail here that's shown, to the test tubes. So one test tube will have copper 2 sulfate in it, the other test tube will have calcium chloride in it. Measure and record the mass of each test tube and the salt. Hold one of the tubes at a 45-degree angle and gently heat its contents over the burner, slowly passing it in and out of the flame. Notice it's not straight up and down, it's at an angle. What you'll start to notice is that there will be condensation, or the water of hydration will be leaving the test tube. What you'll then do is gently heat the entire length of the tube. So continue heating until all the moisture is driven from the tube. So gently move the test tube back and forth over the flame. This might take 2 to 3 minutes. And then set that test tube down in your test tube rack to cool, and repeat this for the other salt sample. Repeat the heating process. Once your test tubes are cool to the touch, measure and record the mass of each test tube and the heated salt. Again, use the beaker as your weighing device so that the test tube doesn't roll off onto the floor. To clean up, rinse your test tubes out in the sink and use your test tube brush to clean off the test tubes, because the salts tend to clump at the bottom and then that can go directly down the drain. Wipe down your lab table and wash your hands. And that's it.